Welcome to 2.1 practice problems. Let's make a box. Okay, now here's a funny thing. Sometimes the problems asked in the practice problem we may not have directly gone over for class, so sometimes we need to go over these things. And let us begin. Okay, a rectangular schoolyard is to be fenced in using the wall for one side and 150. So if we read a question and we don't know what's going on, the first thing we're going to do, let's draw a school. Whatever our school is. And then we have to fence in a schoolyard, and it's going to be a rectangle. So that means one side is going to be longer than the other side. So we have X for one side, X for the other side, and the third side is 150 minus 2X. We don't need this side right here because this is the side of the schoolyard. We're going to fence in the area. And why is it 150 minus 2X? Well, if you have 150 and you take off this X and you take off this X, that's minus 2X. So the area of the schoolyard is 150 minus 2X. And then area is length times width, so we multiply by X to get the area inside. What is the area of the schoolyard when X equals 40? So A of 40 equals 150 minus 2 times 40 times 40. You put that in the calculator just like it's written. Oh, wait, I forgot to close this parenthesis. I'm sorry. Make sure you put 2 parentheses on this one. Let me write this cleaner. Whenever you substitute, use parentheses, but I forgot to use the parenthesis for this one, okay? In the calculator, you have to close parentheses or it's going to do something goofy on you. And if you do 150 minus 80, 2 times 40 is 80. 150 minus 80 is 70 times 40. You should get 2,800 square meters squared. Okay, now what is a reasonable domain? In class, I'll let you guys pick, but the proper domain is 0 is less than X. X has to be bigger than 0. It cannot be equal to 0. It has to be bigger. And now, what we do is take our one side, 150 minus 2X. We set it equal to 0. And then we solve. 150 equals 2X. I added 2X to both sides because it was negative. I divide by 2, and X equals 75. So, has to be less than 75. And the way this works, the smaller X is, the bigger this side is. The bigger X is, the smaller the other side becomes. So, you can pick any number in between there. And there's a number of X that gives you the maximum volume. Okay, Noah finds an expression for V of X that gives the volume of an open top box, blah, blah, all these words. Okay, so now, Noah gets, this is the graph Noah gets if he allows any value to be between -1 and 5. Okay, so this is the graph he gets. But the domain is not an appropriate domain. So, let's look at what's real. Well, 0, we start at 0. And at 2.5, we get back down to 0. We can't go past 2.5 because you cannot have negative volume. And on the other side of 3.5 is unbound. That thing keeps going up and it doesn't come back down. So nothing after this line makes sense. Nothing before this line makes sense because you can't put in negative distance. So we say 0 is less than X is less than 2.5. Well, we could go up to 2.5, but you have 0. Well, you won't have any volume, so I wouldn't say equal to. I would not say equal to. Okay, what is the approximate maximum value of the box? What is the approximate maximum value? So, if this is length and this is volume, then we look for the height of the graph. And you draw a line straight down. So somewhere around 1, the approximate maximum volume is about 15 cubic inches. And I got that from our problem. Okay, May wants to make an open top box, so this relates back to our lesson. Okay, our lengths are 10 and 10. Okay, so now let's make an expression. So we know that you have to cut off 2 lengths, one at either side. So if one side is 10, we take off 2x. The other side is also 10 minus 2x. And then what we cut off is actually x. That becomes our height. Length times width times height. So this is an appropriate expression. And so now, what is the volume of the box when x equals 3? We do 10 minus 2 times 3. 10 minus 2 times 3. And then times 3 becomes 2 times 3 is 6. 10 minus 6 is 4. Times 4 times 3 gives us 48. 48 what? Centimeters cubed. When we're talking volume, the exponent is always cubed. Okay, now let's look at practice problem 4, which goes back to the previous unit. So on day 1, we're at 1/4 square meter, and then we got to multiply by 2. Doubles means multiply by 2. So 1/4 times 2 is 2/4, which is 1/2. Always reduce your fractions, people. 1/2 times 2 is 1, 2, then 4, then 8. Okay, whenever I look at a table of values, the first thing I'm going to do is figure out how this is changing. So we go from 5,000 to 500 to 50 to 5. So if we knock off a 0, that means we are dividing by 10 or multiplying by 1/10. And 1/10 is equal to 0.1. So define P recursively. So for recursive sequence, we need P of 1 is 5,000. P of any number in the sequence is the previous term. Recursive sequence need the previous term times the change. And finally, the next term, n greater than or equal to 2. Okay, there you go. That's a complete recursive sequence. Okay, so we just had Algebra 1 a couple of months ago, and we did quadratics at the end. So your algebra teacher should have told you, multiply the constants and then add them. This gives you the third term. This gives you the second term. Okay, so 4 times 6 is 24. 4 plus 6 is 10. So this is all plus. This goes with that one. So 4 times 6 is still 24, but this is negative 24. So it's one of the top two. 4 minus 6 is negative 2. So 2 goes with A. Negative 4 plus 6 is positive 2. Negative 4 times 6 is negative 24. So that goes with B. And finally, negative 4 times negative 6 is positive 24. Negative 4 plus negative 6 is negative 10. So some of us are going to have to remember our addition and multiplication of integers. So if you have same signs when adding, so this is for adding, same signs add, different signs subtract. This is for adding integers. For multiplying integers, same signs equals positive, different signs equals negative. Or another way, an odd number of negatives, if you're multiplying more than two numbers, an odd number of negatives, odd negatives is negative. Even negatives is positive. Okay, evaluate the function. What evaluate the function means is put the number in. So we put -2 in for x. Make sure you put the number in parentheses to keep the sign straight. First one is 15. -2 times -2 is +4. Because if you put -2 squared into the calculator, you're going to get -2 because of -4 because of PEMDAS. So be careful about how you put these things into the calculator. The whole thing must go in parentheses. And g of 2 is 8 times -2 plus 3 times -2 squared. So we just saw -2 squared is 4. 3 times 4 is 12. Minus 16 plus 12 is -4. And then finally, -2 minus 6, -2 plus 7 gives us -8 and 5, which gives us -40. Now, why do we do this? When you see two parentheses next to each other with no sign in between, it means multiply. So these terms get multiplied to each other, but order of operations, you must do what's in parentheses first.